Everyone, and welcome to lesson 11.0, day 3. Today we are reviewing areas of circles. So last semester we talked a lot about the area of a circle. We talked about the circumference being 2 times pi times the radius, and or you could use pi times the diameter. And then a fraction of the circumference is the arc length, and that's the the measure of the central angle divided by 360 times 2 times pi times r. So in previous topics, we've talked about both of those. Today, we're going to change our focus to mostly be on area, which is, again, going to cover our whole circle. That is pi times the radius squared, or an area of a sector, which is just a fraction of that, which is the central angle measure, the arc measure, divided by 360 times the pi times the radius value squared again. Okay. So finding the area of our circles with a radius of 9. So we're going to type that in as pi times that radius value squared. A reminder, on our calculators, we have the pi button, and that's going to give us the most precise approximation of pi. In this case, we'll just round to the nearest tenth. 254.5 would be our approximation for the area, and it's centimeters squared because area is always our unit squared. Now, when they give us a diameter, we are forced to change that to be a radius because our formula, we have to use the radius. So for this one, the area is going to be pi times our radius, which is 7.5 squared. So again, we want to make sure we're using the pi button in our calculator, and then times that radius value squared. This time our approximation, 176.7 meters squared. All right, sometimes we are going to work backwards. Like this time we are given that the area is 144 pi, and we want to know what that radius value is. So times pi times that radius value squared. The pi's will cancel since that was the exact area. And then we can just square root to find our final answer, which is just going to be 12 feet for the radius. Now, if they are asking us for the diameter, again, we are going to set off, they are giving us that the area is 42.25 pi. This time, again, equals pi times our radius squared. So again, our pi's will cancel. And this time when we square root 42.25, we get the radius to be 6.5, right, after we square root. Now, reread the question, however, they are asking us for that diameter, so we need to double that to get our final answer of 13 feet on that one. All right, there is a try question down here. This time we have a circular pool with a diameter of 24 feet. What is the area of that pool cover to cover it? All right, down at the bottom, for example, we are just looking for the area of our sector. So again, we're going to take that central angle / arc measure, which is 72 degrees, divide that by 360, and then this time we'll multiply it by pi times our radius value squared. Now, reminder, they're showing you the diameter is 12. So when we plug in for our radius value, we know we actually are going to be plugging in half of that so that we have the radius value squared. So our angle measure divided by 360 to get that fractional value of our total area, which is pi times the radius, just 1/6. Oh my gosh. So angle measure divided by 360 times pi times the radius value squared is 22.6 centimeters. Again, this is still unit squared because we're talking about area. All right, there is one for you to try. Again, you are going to find the area of the sector, this time with a central angle measure of 120. Make sure you just round to the nearest tenth. All right, on the back, we have a couple different word problems / composites to look at. This time we are making a new landscape design, and we are going to have a flower garden, so this piece right here, with a circular walkway around it as well. And the garden we see is 20 feet in diameter, and the pathway is 2 feet around, and we want to find the area of the pathway. So this area I have of our black figure. So what we can do is we can take the area of that outside part of the whole big circle, and if we subtract away the area of the garden, the smaller circle, we are going to be able to find that remainder, just the pathway area, right? So we want to take the area the big and subtract away the area the small. So if we think about this big total circle, okay, again, we know each of these are 2 feet. So if we take 2 feet, 2 feet, and the 20 that we had before, we have a total here of 24 feet, which is our diameter. However, we know that in order to find the area, we need the radius. So we'll be using 12 on that one. And our total area then is pi times that radius value squared. So about 452.4 feet. Now the smaller one, again, just our green portion inside here, our garden, that we see has a diameter of just 20. Which means if our diameter is 20, our radius this time is 10, area is pi times that radius value squared. So 100 pi is about 314.2. And then our total area, again, this time we only want that outside pathway, so we're going to subtract away that inside circle. So big minus the small, minus the small, which is 314.2, will give us our remainder of 138.2. And again, that's just going to be this leftover black pathway around the outside. That area. In the second example, on the back here, we are given the area, we want the area of the shaded region, given that circle and rectangle. So again, our biggest figure here is the area of our circle. And if we subtract away from it the area of the rectangle, we will have our leftover total area, right? So if we start off with the area of our circle, okay, we need the radius of that. Well, we can't necessarily find the radius right off the bat, okay, but what we can find is the diameter, which is the diagonal of our rectangle. And we can find that diagonal value by using Pythagorean theorem, because the diagonal squared is going to equal the two sides squared and added together. So that's 2,500. And when we square root, our diagonal ends up being 50. Okay, and that again is the diameter of our circle. Well, if our diameter is 50, we know the radius is half of that, 25. And then the area will be pi times the radius value squared. So pi times 25 squared is 1,963.5. Now the area of the rectangle is just our base times our height. So the base of the rectangle is 40. The height is 30. 40 times 30 is 1,200. So again, to find our total area this time, we're going to take the area of the circle, which we said is 1,963.5, and then the area of our rectangle, which is 1,200. And when we subtract those, we get our final, which is 763.5 units squared on that one. All right, last example together is one of our composite figures. Now notice this time they are telling you that this figure in quadrant 3 is the quarter of a circle. And if you think about drawing in this whole circle, what we notice is that our radius is essentially the side length of this quarter circle that we have so far, right? So if we take the area of the whole circle and just divide it by 4, that's what the area of our quarter circle would be. And this time, if we count up our units, our radius here is 7. So pi times that radius squared would give us the whole circle. We only want a quarter of it though, so we're going to divide it by 4. So we can take pi times our radius squared divided by 4, and we get about 38.5 for the area of our quarter circle. Well, now we also have a triangle whose sides are 7 and 7 as well. So the area of that right triangle is 1/2 the base times the height. So 1/2 of 49 is 24.5. And then last but not least, we also have a rectangle. And this side is 5, this side is 9 when we count the units. So for the area of our rectangle, base times height would be 45 units. Now our total for area for this composite figure will come from adding up those 3 areas, and we get a total of 108 square units as our composite figure. All right, for this last one, you are going to find the area of the composite figure. Notice the areas of a semicircle. So think about half of your area of a circle, given that radius. And a reminder that radius can also help you find the height of that rectangle. You want, again, the total area of that composite figure. Thanks everyone for watching. We'll work more with these in class.